Now this is continuation of inverse of a mapping. So it is problem number 4. Let a equal to r minus minus half and b equals to r minus half. Prove that the function f from a to b is defined by fx equals to x plus 2 by 2x plus 1 is invertible, and hence find f inverse. That means invertible means we have to first check that f is bijective or not. So how to check it? For the injective part, let fx equals to fy, where x comma y belong to a, where a is a domain. A is a domain. Got it? So x plus 2 by 2x plus 1 equal to y plus 2 by 2y plus 1. And after simplification, we get x equal to y. Sure? And this shows that f is injective, obviously. And for the surjective part, let y belongs to b, codomain of f, then fx equals to y. Now cross multiplying, so we have to find x in terms of y, and that should be belongs to a, because this one not equal to 0, obviously 2y minus 1 not equal to 0. That why? Because y belongs to b and b is your what? R minus half. That means y not equal to half. Y not equal to half. This implies 2y minus 1 non-zero. So this should be belongs to a. Got it? Now we have clearly checked that this x belongs to a. That means x not equals to minus half. Sure? How to show it? You see my previous class. Okay? So thus, for each y belong to b codomain, there exists x belongs to a domain such that fx, and put the value of x here, and after simplification we got y. And this shows that obviously f is surjective, and since f is injective and surjective, so it is bijective. So f is invertible. Since f is bijective, so f is invertible. That is, f inverse exists, and f inverse is given by x equal to f inverse of y. That means f inverse of y equal to, what is the value of x? 2 minus y by 2y plus 1. Put it. Therefore, f inverse from b to a, f is from a to b, so f inverse from b to a is given by this y and y replaced by x. F inverse x equals to 2 minus x by 2x plus 1 for all x belongs to b, because the domain is your b. Sure? Number 5. Consider f from r plus to semi-closed interval 4 comma infinity given by fx equals to x squared plus 4. Show that f is invertible with the inverse f inverse given by f inverse y equal root under y minus 4, where r plus, this r plus is a set of all non-negative real numbers. Non-negative real number. That means r plus means r plus equal to semi-closed interval 0 comma infinity. Got it? So now for the injective part, let fx equals to fy, where x comma y belongs to r plus, where r plus is the domain, obviously. Then x square plus 4 equal to y square 4 plus 4, and x plus y into x minus y equal to 0. And look at that, x minus y equal to 0, and this x plus y non-zero. Why? Because x comma y both are belong to r plus. That means both are non-negative. That means positive or 0. Now if x and y both are positive, so x plus y cannot be 0, except when this will be 0, then when x equal to y. Got it? X equal to y equal to 0, then x plus y should be 0. So x equal to y. So this shows that f is injective. Now for the surjective part, here we will apply the procedure that if range of f equal to codomain, then the function is surjective. So look at that. Consider x belongs to r plus. R plus means set of all non-negative real numbers. So x should be greater than equal to 0, obviously. So now since x greater than equal to 0, so x square greater than equal to 0. So x square plus 4 is greater than equal to 4, obviously. And that x square plus 4 equal to fx, in your question it is given fx equals to x square plus 4. So fx is greater than equal to 4. That means range of f equal to semi-closed interval 4 comma infinity, and that should be your codomain. See that r plus 2 semi-closed by 4 comma infinity. So here we see that range of f equal to 4 comma infinity equal to codomain of f. So f is surjective clearly. Hence f is bijective. So f is invertible. That is f inverse exists, and f inverse is given by f inverse y equals to x. And now if we consider y equal to fx, since the function is surjective, we consider y equal to fx. What is the value of x? Fx, x square plus 4. So x square equal to y minus 4. So x should be root under y minus 4. We cannot take plus minus. We cannot take minus because x belongs to r plus, mean x should be greater than equal to 0. So there can be x cannot be negative. So we cannot take the negative sign. So we only take the positive sign. So x should be equal to root under y minus 4. Put instead of x root under y minus 4. Therefore, f inverse from 4 comma infinity to r plus is given by f inverse x equal to root under x minus 4. Sure.